So one more balancing equation problem that we're going to work through. Remember our steps? First step was look at the equation, determine which of the particular compounds in that equation, the reactants or the products, which one of those reactants or products is probably the most complicated. Remember I talked about the idea of complicated? A very unscientific term the way I think about this. I just look for the one that has the most atoms in it. And for me, that makes it an easy place to start. Now, this won't work every single time that we work on a problem. There are, maybe 1 to 5% of equations that are going to be much more difficult to balance, but that works very well as a general rule. And so I look at this and I say, okay, UF4 has 5 atoms. That's more than any other compound here. So I'm going to place a 1 in front of it. Place that 1 in front of that UF4. Since this compound is the only source of uranium and fluorine, I can go ahead and figure out how many uranium atoms and how many fluorine atoms. And I have 1 uranium atom and 4 fluorine atoms, because I've balanced that already. Now, I haven't balanced anything else, so I can start to try to balance some of these other compounds. And so what I'm going to do is, I'm going to say, okay, this is the only source of uranium here. If I put a 1 in front of it, there's only one of them. So I must only have 1 uranium atom on this side as well for it to be balanced. And it better be 1. So how do I get 1 uranium atom over here? Well, I put a 1 in front of that UO2. That gives me 1 uranium atom. Also said fluorine. I've got 4 of them here. I better end up with 4 fluorine on this side. And so HF, that's my only source of fluorine on this reactant side of the equation. I need 4 fluorine. I'm going to put a 4 there to give me that 4 fluorine. Now, I've balanced both of the compounds, both of the reactants, so I can figure out how many hydrogen atoms and how many oxygen are there. So, hydrogen's only here. I've got 4 of them, so I need to make sure that I get 4 hydrogen over on that side. And oxygen, I've got 1 of this compound, this UO2, so I've got 2 oxygen atoms. Come over to the other side. What do I need? I need 4 hydrogen atoms. Got them here in groups of 2 because each molecule has 2 hydrogens. So I must need 2 of those waters. 2 times 2 is 4. That gives me my 4 hydrogen. 2 times 1 oxygen would give me 2 oxygen atoms. Everything match up? Indeed it does. We must be balanced. You can go back and check by counting again. That's a double check. But I'm pretty sure that we're right on the money whenever we solve it this way. Just work through it iteratively. The key, starting with the most complicated molecule as either a product or a reactant. Doesn't matter which one. Could be either. Pick that one, put a 1 in front of it, and start from there. It gives you a great place to start.